Alright, so next will be a type 3 problem. Type 3. They ain't got no type 3 diabetes. Nobody invented it yet. They don't invent these things. They don't. What am I talking about? I don't know. Doesn't matter. Doesn't matter. I don't care. So this problem will be parentheses, because that's what type 3 is. That's what type 3 is. Parentheses. So we'll have 2b plus 1 all over b quantity squared equals 2b plus 1 all over b plus 6. This isn't in standard form. I could do it over here. We need to make it look like these equations where everything is to the left of our equal sign and then 0 on the other side. So we can subtract 2b plus 1 all over b to the other side, and we can also subtract the 6, so I'll end up with 2b plus 1 over b quantity squared minus 2b plus 1 over b minus 6 equals 0. Now I'm putting the squared term first, the non-squared term second, and the constant third, just like kind of like standard form for quadratic equations. Now I need to choose my z, and I look at the middle term to choose z, and I just do whatever's in the parentheses. So let 2b plus 1 all over b, let that equal z. And then if we squared both sides, this is kind of tricky. I'm trying to get this term. So if I square both sides, I don't really have to square it out. I can just write 2b plus 1 all over b, and I can just write a squared there, because then it looks like this, and that's what I want. Equals z squared. I just squared both sides. Then I make the substitution. So instead of this squared, we can write z squared. Instead of this, we can just write z. So minus z, and then minus 6 equals 0. Again, we can factor this. I'm not going to show you the diamond problem. I'm just going to go ahead and factor it. It'll end up being z minus 3 times z plus 2 equals 0. So our z's are 3 and negative 2. So we're not done yet, of course. We still have to find out, in this case, what b is, because that's our variable here. So I'm going to go back and say when z equals 3, that's the first value. When z equals 3, what does this whole thing equal? So I'm looking for this step. It's a little bit confusing. I'm looking at these equations. Okay, so 2b plus 1 all over b equals z, but z is 3 in this case, so I can write a 3 up there. And if I multiply both sides by b, I'll get 2b plus 1 equals 3b. Subtract 2b from both sides, and I'll get 1 equals b. So b equals 1, that's one of our answers. And that was when z equals 3. How about when z equals negative 2? And again, I'm using these equations, whichever one is most convenient. Since I know what z is, I'm going to use this one. That's what I've been doing. So I'll have 2b plus 1 all over b equals negative 2. Multiply both sides by b, and I'll have 2b, well not 2b, 2b plus 1 equals negative 2b. Subtract 2b from both sides to get 1 equals negative 4b, which means b equals negative 1/4. Is that what I ended up with? Yeah. So our solutions now to this equation are 1 and negative 1/4. That's all we gotta do. That's all she wrote. But I'm a guy. That's all I wrote. I don't. What? I don't know. So I'm just going to give you guys a couple examples to work out. You can pause it and work them out on your own, and then see what I do. So, example. And this will be x to the negative fourth plus 5x to the negative half, no, negative 2 minus 36 equals 0. This is almost a type 2 problem, except for we have negative exponents. Doesn't matter, we do the same thing. Let the middle term variable, let x to the negative 2 equals z, square both sides, then x to the negative fourth, that's what we wanted, good, equals z squared. Do our substitution. You can't factor this one, by the way, just to let you know. We'll have z squared plus 5z minus 36 equals 0. Since I already know we can't factor it, you can try factoring it, but you can't. We'll use the quadratic formula. So z will equal the opposite of b plus or minus square root of b squared minus 4ac all over 2a. So we got to find out what a, b, and c are. So a is 1, b is 5, and c is negative 36. So opposite of b is negative 5 plus or minus square root of 25 minus 4 times 1 times negative 36 all over 2 times 1. And that equals negative 5 plus or minus square root of 25 minus 144 all over 2, which equals negative 5 plus or minus square root of 169 all over 2. Square root of 169 is 13, so we'll have opposite of 5 plus 13 over 2, or negative 5 minus 13 over 2. We can simplify this. Negative 5 plus 13 is 8, right? 8 divided by 2 is 4. And then 13 plus 5 is 18. Divided by 2 is, or negative 18. Divided by 2 is negative 9. So this is z, and we don't want z, we want x. So we still have to figure some things out. So when z equals 4, we can use these equations. So with the blue, we'll have the blue. When z equals 4, x to the negative 2 will equal 4. So what does this mean? We can flip this over. It's a crying baby, right? 1 over x squared equals 4. Multiply both sides by x squared, and then divide by 4, and we'll get 1/4 equals x squared, which means we can do that. Square root both sides to get plus or minus 1/2 for x. Okay, we're square rooting both sides. I can show that. Okay, so that's when z equals 4. What about when z equals negative 9? Do the same thing. X to the negative 2 equals negative 9. We can put the crying baby down because they don't want to be picked up. So 1 over x squared equals, remember we had that 100-pound baby? Whew, it was huge. I don't know if all the blocks had the 100-pound baby. Oh well. Do some magic. If we multiply both sides by x squared and then divide both sides by negative 9, we'll get negative 1/9 equals x squared. Square rooting both sides. Go square, go square. Square rooting. We'll have plus or minus 1/3 I equaling x. So our solutions are plus or minus 1/2 and plus or minus 1/3 I. Now we are done because we solved for x.